Hello there. Today we'll be doing largest rectangle in histogram. So this is a stack problem again, and what we're doing here is looking for the largest area in these histograms. So the largest would be 5 by 2, and that would be this particular location. So we can use a stack to record the heights of the histograms, and once we see a height that is of a lower height, that means that we can start calculating this particular histogram. So suppose you have 2 and you look at the next item. Oh, it's a 1. That means you can't expand that histogram anymore. That means the only way is to calculate it from this point to from this particular start point and to this end point and this particular start point, which was 1. Like 1 minus 0 is 1. Okay, so let's type that out. So I mean, that's the best way to see it without doing too much work. Well, seeing is helpful. So now we have a stack, and we have an item called let's say an index and the height, which is 2. So at this point, what we're gonna do is this is our index. Now we moved it to 1, and we found a lower height. If lower height, that means that it's time to pop the stack, and calculate max area. So let's pop that stack. So we pop it, and we have a width of 1 minus 0 and the height of 2, which gives us a max area of 2. So the stack is now empty, but now let's insert the items back into the stack. So to insert items into the stack, we have one height, but it starts at 0 because that's the most like earliest point we have popped off. So it can start at 0. So because I mean the 1 starts at 0 at the point it pops off, right? Because it's lower. All right. So let's move on to the next item. Next item is a 5. 5 is going to be much taller, so there's no popping at this point. So let's just keep adding on to our stack. So this is going to be started at the 2 and a 5 immediately. So next item, 6. So 6 is taller, so we just throw a 3 and a 6 in. Then we find a 2. Find a 2. That must means that this is a 4 and 2, 0, 1, 2, 3, 4, 5. So this is a 4 and 2, and that means we need to start removing items now. That means it's a lower height. So the height's going to be, at this particular point, a 6 and a 3. So 4 minus 3 is 1. So that's the width. And the height is going to be 6 minus 2, which is going to be 4. And the max height is now 4. So let's remove that, and let's get the next one. So next one is going to be 4 minus 2, which is going to be 2 of width, and the height is going to be 5 minus 3. 5 minus, well, not 5 minus 2. Did I mess up somewhere there? No, the height's going to be 6. Sorry. So the max height is going to be 6. So the height is now 5. So 5 times 2 is going to be 10, a total of 10 area. Now we'll remove that, and let's check the next one. Okay, well this is this height is higher now, so let's just add this item back into the stack. Whoops. Okay, so now let's check the next item. Next item is 5 and 3, so it is a higher height. So let's just keep adding it to our stack. So now we have our stack, and nothing has been, we still haven't finished up all of work yet, but let's start working through it. So what's going to happen here is that we're going to get the last height, the end of the number of heights. So 5 minus, well, index is 5, so it's 6 items minus 5 index, which is equal to 1. and we multiply by 3. So width and height is equal to 3. So we'll take that out, and that's going to be our new, that's going to be 5 times 1 times 3, which is only 3, area of 3. That's too low for a max height of 10. So then we tried it 4 and 2. So 6 minus 4 is 2, because we used our number of items as our final index. And now we have a width of 2 and a height of 2, which is going to give us an area of 4, which is still less. So now, lastly, we're going to have a 1 and 0. So width is going to be 6 minus 0, which is 6. And it's going to have a height of 1, so area 6. 6 is still, like this whole area 6 is still lower than our max area of 10, so we return the max area of 10. Okay, I think that's enough explanation. Let's just start coding it out now. Give it a go. So we need a stack to store. We need a max area to keep store a max area. Well, we need our index, and our height in enumerate heights. We're gonna start. We're gonna iterate on these variables as they become more clear about what these variables should be named. But right now it's a little bit bland, and we don't know enough about the problem to know exactly what these variables should be named. Once we do know, we're gonna name them properly, and they will be better to help us trigger the memories when we read this code again. Okay, so here we go. What we're gonna do is stack.append. Usually we need the start index and the height. Okay, so this is the current, well, let's say the height. So this is gonna be start index. Let's say start index is equal to I, and height is equal to h for now. We're gonna change that a little bit if necessary. Okay, so while stack and stack of -1, the previous item, and its height is well, less than, well, no, greater than. It's greater than the current height. So it looks like we have to change the name again. So current height. Let's change that, and here we go. With that, we have we can set our previous height and previous height index to be equal to stack.pop. With that, we can calculate the width. Width is equal to well, the current height, well the index minus the previous height index. So I think this is going to be called current index as well. Maybe to be more clear, maybe current height index. Okay, maybe too long, but I don't know. We'll check it out. Start soon. So current height index minus the previous index, and the height is the previous height. So we can get the max area now equals max of max area and the previous height times width. With that, we are done with this particular part, and I think we do need to update the start index. The start index is equal to well, the previous height index. Okay, I think that's about right. So what do we need? So do you think this should change? Well, let's run this code first, make sure everything works. One more thing is that there should be still items in the stack. While stack, we're going to do stack.pop. So that means the index and height is equal to stack.pop, and well, the width is equal to length of the heights minus the index, and the max area equals the max of max area, and the width times height. I think that should be good to go. Alright, looks good. Okay, so I think there's a lot of code that we need to clean up, but it looks like it's working pretty well now, and it's time to start cleaning up this stuff. So the first thing we need to clean up is that this H, looks like we can just change that H here, and we don't need this line of code. Current height index equals start index equals I. Can we do the start index is equal to the current index at this particular point, and then change start index? I think that's a little bit more clear about what's going on rather than making it equal to I. So that doesn't make too much sense. So let's change that. And now we have a little bit longer items. So now previous height index looks good. Current height index minus previous height index. The height. So I think that looks about right. So while stack, index, and heights, what do you think about that? How about height index? I think that makes a little bit more sense. Anything else? I don't think so. I think that's good. Let's see. Submit. The timing is going to be a little bit off because, yeah, that's just the way it is. So I think this wording is a little bit better. Hopefully it makes a little bit more sense. And yeah, looks pretty good. Is there anything else? I don't think so at this particular point. I think this looks pretty good to me. I think the next time I read this, I will be able to clearly identify what is exactly going on here. I think a comment somewhere would help. Let's see. Maybe a comment here. If current height is lower than previous height, then pop from stack and calculate max area, because lower height, I mean the higher height cannot continue forward and grow. Okay. I don't know if that comment will help in the future. Let's see what we should do. Anything else? I think that's a good comment to have right there. add items to stack for computation, and clean up stack with items that run the full width, that reach, that has width until at last index. Okay, hopefully those comments help trigger some memories next time I read this code. I think that will be good. Eventually, I think these comments will go away as this code gets better, and maybe even we don't even need to, maybe if we read it a couple times and we change this code to the point where we don't need these comments anymore. But they're pretty okay comments for learning at this point. I'm not sure if next time I read this, maybe I'll erase the comments and then try to read the code before looking at the comments, and maybe we'll see something. Yeah. But I do think the comments do help, like quickly get my understanding about what's going on here. Yeah. So I think maybe a comment on the general formula here. Build up stack to the max width for each height. I don't think that makes too much sense without context about what we're trying to do here. We'll see when we read it next time. Alright, if you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.